continued. So yesterday I had you add a couple things to your card. Let's just talk about those couple things. One of them was that x equaled r cosine theta, and that y equals r sine theta. I also said one of the things we're going to need to use is that r squared equals x squared plus y squared, which is just our circle formula. And then the last thing we may need is that tangent theta equals y over x. So the first thing we're going to do in the first section today, you've got to change it from polar coordinates into rectangular. So I want to talk about that first. We're going from polar to rectangular. And it's an equation you're doing first. Oh my goodness. All right. So in the equation, if it is equal to r, the first thing you should do is multiply both sides by r. Step 2, replace all r values. So for example, if we have r squared, you're going to replace it with x squared plus y squared. If we have r cosine theta, you're going to replace that with x. If we have r sine theta, you're going to replace that with y. Okay? So all r values you're going to replace. Then step 3, you're going to simplify the equation. All right. So let me kind of show you what I mean here. Here's example number 1. This is going to be from 35 through 41. And convert to rectangular. And that's what we use every day. So let's say I have r equals, start off really easy, -4 cosine theta. Very first thing we're going to do is multiply both sides by r. So on this side, I'm going to have r squared. On this side, I'm going to have -4 r cosine theta. Step 2 says replace any r values. So r squared we can replace with x squared plus y squared. On this side, we can replace the r cosine theta with x. Now, here's where the fun begins. This we know is going to make a circle. We do. This right here, we're going to have to move over and complete the square to figure out where the center of the circle is and what the radius is. So hopefully we all remember how to complete the square. Let's see where we're at. So to simplify this equation, the first thing we're going to do is move our -4x to the other side. So I have x squared plus 4x. I'm going to leave a blank because I've got to complete the square, plus y squared equals. Actually, I can put a blank on that side too. That might make it easier. When we complete the square, we take half of this number and square it. So half of 4 is 2. So I square that, I get 4. Whatever I add to this side, I have to add to this side. Now, this one right here makes a perfect square. It is x plus half the middle number, quantity squared. If I were to throw this in the x, 4 on top, 4 on the bottom, my sides would be 2 and 2. So I get x plus 2 squared. And then I have plus y squared equals 4. This is a circle with a center at -2, 0 and a radius of 2. So did I lose anybody anywhere? How are we? Are we okay? Right when in the beginning I said x equals r cosine theta. Okay, you're good? All right, let's try one more from this section so you guys can see how that works. And then we'll do a couple from the other section that go the other direction, and then we'll be good. All right, so how about if we do, let's do one a little bit, do you want one harder or different? Different, okay. Let's do one like this. What if I have r equals -2 cosecant theta? So this one's a little bit different, obviously, because it has a cosecant in there. First thing I'm going to do is multiply both sides by r. So I have r squared equals -2 r cosecant theta. All right. R squared we know equals x squared plus y squared. We have a problem over there, though. This is actually, right here, 1 over r sine. Oops, actually my r stays on top. Sorry. This is actually r over sine theta. Well, we don't have anything for that, do we? So everybody's good? So we've got to figure out what else we can do with this. So I'm going to write this as -2r over sine theta. Actually, you know what? Let's make this easier. I was going to make this hard on you. Can I make it an easier way? You guys okay if I back up just a little bit and make it easier? Okay. So I'm just going to draw a line. Let's start over. Let's, at the very beginning, let's change. So we have r equals -2 cosecant theta. Let's change that to 1 over sine to begin with. Okay? So I have r equals -2 over sine theta. Everybody okay there? Okay. I was going to take you a long way. We're just going to make it easier. If I do that, because it's not a trig function we have, and sine's now on the bottom, I can multiply that to the other side. So I have r sine theta equals -2. Now, do I have something I can replace r sine theta with? Y. So this is actually just y equals -2, which is just a horizontal line. That's all this is. Okay? So I think this is much easier than the first way I was going to take you. All right? Let's do one more similar to that. I'm just going to draw a little line here. Let's say I have r equals 3 secant theta. So what would we decide to do here? Yeah, so r equals 3 over cosine theta. Then what can we do? Perfect. So r cosine theta equals 3. Yeah, so this switches out for x, so x equals 3, or just a vertical line at 3. Okay. Would you guys like one more where we complete the square? Yes? Okay. So let's do one more. Let's go example number 4. No, number 3. Sorry. Example number 3. Let's say I have, we'll do a tougher one. R equals 4 cosine theta plus, no minus, 4 sine theta. We'll do that. All right, so on this one, the first thing I'm going to do is multiply both sides by r. because these are regular trig functions. So on this side, I'm going to have r squared. On this side, I'm going to distribute my r to everything. So I have 4r cosine theta minus 4r sine theta. Now I can switch out my r squared for x squared plus y squared. Over here, I can switch out my r cosine theta for an x. And I can switch out my r sine theta for a y. Now we're going to move everything to the other side. Okay? So I'm going to have x squared minus 4x. I'm going to leave a blank here because I'm going to have to complete the square. I have plus y squared minus 4y. I'm going to leave a little blank here because I got to complete the square. Equals whatever I put on that side. All right, completing the square. I take half of negative 4, which is negative 2, and I square it. I get 4, which means I'm going to put 4 over here. Now I got to do my other blank. I take, oops, that's a plus 4. Nobody even got me. I take half of positive 4, which is 2, and square it. Positive 4, so I'm going to add 4 to this side as well. Any questions so far? All right, so this is going to be my first perfect square right here. If I were to draw my x, 4 on top, negative 4 on the bottom, what are both of my sides? Negative 2 and negative 2. So this one is x minus 2 squared plus, now I've got to do this one, which is y plus 2 squared equals 8. So I have a center at 2, negative 2, and a radius of square root 8 or 8 root 2. Or no, 2 root 2. 2 root 2. My goodness. All right. Now we're going to talk about changing it from, do we have questions here? Anybody at all? The radius is just the square root of the number on the end. So the square root of 8. Yeah, it's just, that's our circle equation. All right, so let's talk about going from rectangular to polar. So if we're going from rectangular to polar, that means that we're switching out all x values and x squared plus y squared values. So if there are x squared and y squared, we want to first, if there is, isolate x squared plus y squared. Step 2, you're going to switch or replace all x and y values. And then 3, you're going to divide by r. Now that's if we have an x squared and a y squared. If we don't, you're just going to switch out x and y, and you get to skip that first step. Okay? So let's talk about a couple of those. Here's example number 5, I think. And this is what you're doing for 43 through 49. Let's start with an easy one. Let's say I have x equals 7. I don't have any x squared or y squareds in here, so I'm just going to replace x. On my card, I know that x equals r cosine theta equals 7. Now I need to isolate r, which means I'm going to divide by cosine. So r equals 7 over cosine theta. Well, I don't leave cosine in the denominator. So I get r equals, how else can I write cosine in the denominator? I can write this as secant, or 7 secant theta. All right, let's try example number 6. Let's say I have x squared plus y minus 1 squared equals, let's just say equals 1. Sounds good. All right, so the first thing we have to do is we are going to have to isolate x squared plus y squared. To do that, I have to multiply out that beautiful y minus 1. So this right here, get x squared plus y minus 1 is squared is y minus 1 times y minus 1. So I get y squared minus y, and positive 1. So y squared minus 2y plus 1 equals 1. So then I need to get x squared plus y squared all by itself. So I'm going to keep x squared plus y squared on the left. I'm going to move everything else to the other side. So I have 2y, and when I subtract 1 over, what happens to the 1 that's there? They cancel, absolutely. So now we're going to change out our x squared, y squared for r squared, and we're going to change our y out for r sine theta. And what's the last thing we have to do? Yep, so we got to divide both sides by r. On this side, we're going to be left with r equals, which means it's polar, right? On this side, I have 2 sine theta. Any questions? Feel like I'm losing you. Am I losing you? You don't even know? How about we just try the problems and see what happens? Does that work? It's just algebra stuff. We can do it. We got it. I am confident in us. There's none over there?